I'm going to be going over inequalities in one triangle. So first of all, we need to go over the exterior angle inequality. And this says that the measure of an exterior angle is greater than the measure of each remote interior angles. So again, that's the measure of an exterior angle is greater than the measure of each non-adjacent interior angles. So you can think of this kind of like the exterior angle theorem of a triangle. So A, B, and C, and we're going to call this angle 1. Our exterior angle is called angle 1. So remember that the exterior angle theorem says that the measure of angle 1 should equal the measure of angle A plus the measure of angle B, the two angles inside the triangle that aren't right next to it. That's what the exterior angle theorem says. Well, this exterior angle inequality says that angle 1 needs to be bigger than each of those angles that we use whenever we're doing the exterior angle theorem. So that the measure of angle 1 should be bigger than the measure of angle A, and the measure of angle 1 should be bigger than the measure of angle B. It should always be that way. So an example problem is, well, I'm going to pause and draw this triangle because it's pretty detailed. And then you pause and, well, you know what? You're going to draw it with me because I think that that would be easier. All right, so here is my triangle. These have arrows. And this is Q, R, P, angle 1, angle 8, angle 2. And we have another triangle on the inside in here. Okay, this is 3 and 4. This middle right here is S. This is 7, 6, and this is 5. Okay, so it says, which angles are less than the measure of angle 1? Which angles are less than the measure of angle 1? So, measure of angle 1 is out here. Remember that it has to be the measure of the two non-adjacent interior angles. So, it would be these two together, okay? And then these two together. So, the measures of angle 3 plus the measure of angle 4 would be 1. And then the measure of angle 5 plus the measure of angle 6 would be the other one. All right, let me get rid of those highlights because we got one more. And the second one says, which angles are greater than the measure of angle 8? Which angles are greater than the measure of angle 8, instead of writing all that out. All right, so the measure of angle 8 is here. So the measure that would have to be bigger than the measure of angle 8 would be this one, because that's what it says, that exterior angle has to be bigger than the two non-adjacent. So 2 would have to be bigger than 8. 2 would also have to be bigger than 5 and 6 together. That's not what it's asking. It's asking 8. So 2 would have to be bigger than 8. Also, 1 would have to be bigger than 8 because those make a linear pair. So the measure of angle 2 and also the measure of angle 1, each of those would have to be bigger than 8. All right, then we have the angle side inequalities. And that's easier explained through some pictures. So all that it says is that your, here, let me just draw an angle. I mean a triangle. Okay, let's say that C is, I don't know, 95 degrees, A is 30 degrees, and that would mean B would have to be 55 degrees. Okay, so obviously C is your biggest angle, B is your middle angle, and A is your small angle. So what angle side inequality says that across from your biggest angle is your longest side. Across from your smallest angle would be your smallest side. And then, of course, across from the middle angle would be your middle side. All right, so example problems. So we need to list them in order from smallest to largest. Angles. Angles. Whenever they give you sides, you have to list the angles. So smallest to the largest angles. So my smallest side is here. The angle across from that is angle B. And then my middle side, the angle across from that is angle C. And then my largest side is 7. The angle across from that is angle A. So my answer is BCA. My other example is if you have this triangle, I'm going to call it WYX. This is 90 degrees. This is 51 degrees. So first of all, 51. I know that looks like an 81. 51 degrees. So we would need to find the third angle first. So to figure out this angle, it would be 180 minus 90 minus 51, which makes it 39 degrees. And then it wants you to list it from the smallest to the largest sides. So my smallest angle is 39. My side across from that is WY. My medium angle is 51. My side across from that is XY. And then my largest angle is Y. The side across from it is WX. All right, so another thing I want you to pay attention to, and we're going to look at both examples, is the sides that go with the angles and the angles that go with the sides are always missing a letter. So this is what I mean by that. My smallest side on my first example is AC. The letter that AC is missing is B, and that's my smallest angle. And then for my middle side is AB. The letter that's missing from side AB would be angle C. So it's the letter that's missing. Same thing with the sides. My smallest angle over here is X. The letter that's missing, or letters in this case, that are missing from X are W and Y, and that is my smallest side. So it's the letters that are left. Those are always your answers. All right. Next example. All right, so we need to list the angles and sides from largest to smallest. And this is our triangle, PMQ, P is x minus 1 degrees. M is 2x plus 3 degrees. And Q is x plus 6 degrees. All right, so first of all, we need to figure out what all those angle measures are. So all angles of triangle have to add together to be 180. Add all the x's together, 2x plus x is 4x. Add all the constants, 6 plus 3 is 9, minus 1 is 8. And all those have to equal 180. So just in case you're not sure what I did this plus this is that. That's all I did. I added all of those pieces together. Subtract 8 on both sides, and 4x is equal to 172. Then divide both sides by 4, so x is 43. All right, angle P is 43 minus 1, so 42 degrees. Angle Q is 43 plus 6, so 49 degrees. And then angle M is 2 times 43, which is 86, plus 3, which is 89 degrees. All right, so my angles from largest to smallest is angle M. And then my middle angle is angle Q. And then my smallest angle is angle P. Now remember, the sides that go with these are the ones that don't have these letters. So the letter that's missing from M is Q and P. The letter that's missing from Q is M and P. And the letter that's missing from P is M and Q. So you don't necessarily have to look. We can always check. Across from M is PQ, which is QP, same thing. Across from Q, come here, there we go, is PM or MP, either way. And across from P is MQ. MQ. So it works. And let me erase all this craziness I drew all over this triangle. All right. So my next example is this crazy triangle. Okay, D, H, G, E, F. This is 48 degrees, 120 degrees, 32 degrees. This little thing here is 17 degrees, 113 degrees. All right, so we need to first find all of the missing angles. But what it wants us to do is to compare, right, greater than or less than for these side comparisons, DH and GH. How do they compare? DE and DG, how do they compare? And then EG and FG, how do they compare? Okay. So first, let's fill in all of my missing angles. So this angle right here can be found by doing 180 minus 113 minus 17. So that would give me 50. Now let's see. This angle here, I would do 180 minus 120 minus 32, and that would give me 28 degrees. Okay. So this one here, I would do 180 minus 113 because those are a linear pair, the two right next to each other. And that would give me 67 on this one. And then this one, I would do 180 minus 48 minus 67. And that would give me 65 degrees. So those are all my missing angles. All right, so let's talk about this. DH is this side, which corresponds to 32. And then GH, where's GH? Oh, GH is this side, which corresponds to 28. So obviously 28 is going to be smaller than 32. So this one is the 32, this one's the 28. So DH is greater than GH. Oh wait, whenever you're, well, whatever. All right. Well, let's see if I can erase these highlighter marks without erasing everything. Okay. DE. All right, DE is here. So the angle that goes with it is 65. And then DG is here. So the angle that goes with it is 67. So this guy is 67, this guy is 65. Obviously the 65 is smaller, so DE is smaller than DG. All right, then the next one. EG is this side, which I'm assuming we're going to use this new one, which would go with the 50. Otherwise, it would go with the 48. It just depends which triangle it's talking about. Yeah, it is this one. So FG is this side, which goes with the 113. Obviously, 113 is way bigger, so this one goes with 113. This one goes with the 50, so EG is less than FG. Or smaller than. Which you can kind of tell even just from the picture. But again, you don't want to ever assume anything. All right, then we have the triangle inequality theorem. Which the triangle inequality theorem says the sum of any two sides of a triangle must be greater than the third side. So whenever you have a triangle, let's call it A, B, C, but I'm going to color code. Red is AB, green is BC, and purple is AC. So AB plus BC, actually I'm going to pause. AB plus BC has to be bigger than AC, and BC plus AC has to be bigger than AB, and AC plus AB has to be bigger than BC. So any of the two sides, when you add them together, has to be bigger than the third side. But if you're given angle measures, not just letters, but actual numbers, all you really have to check is the small side plus the medium side bigger than the large side? Now, again, you can only use that if you're only given numbers, but that's all you really have to check. So what I mean by that is, in our first examples, if we have sides of 8 inches, 15 inches, and 17 inches, all you really have to say is 8 plus 15, is that greater than 17? Well, yes, it is. And that's all that really needs to check. Is the small plus the medium, is it bigger than the large? Because the other ones are all going to work as long as the small plus the medium is bigger than the large. So then another example is 6 meters, 8 meters, and 14 meters. Is 6 plus 8 greater than 14? No, it's not. So this one would not make a triangle. Whereas this one would make a triangle. All right, but if you are given, I do have enough room. Yeah, I think so. If you're given a triangle, and I'm going to draw it over here so we are given enough room. This is X, Y, and Z. And this is for X minus 1, X plus 13, and then 2X plus 7. All right. I'm going to color code these so we can keep track of them. So remember I told you any of the two smaller sides have to be bigger than the third. Whenever you're given equations like this, in order to know how to solve it, we have to set up all of those inequalities. So we're going to have 4x minus 1 plus 2x plus 7 has to be bigger than x plus 13. So just so we can keep track, that is pink plus yellow is bigger than green. Then we need 2x plus 7 plus x plus 13 has to be bigger than 4x minus 1. That is yellow, and green has to be bigger than pink. And then the last one, x plus 13 plus 4x minus 1 has to be bigger than 2x plus 7. And that is green plus pink has to be bigger than yellow. All right. And you know you've done it right as long as these ends are all three different, which they are. One's green, one's pink, one's yellow. Okay, so let's solve these. 4 plus 2 is 6x. Negative 1 plus 7 is 6. Has to be bigger than x plus 13. Subtract x from both sides. That gives me 5x plus 6 is greater than 13. Subtract 6 on both sides. That's 5x is greater than 7. Then divide 5 on both sides. X has to be bigger than 7/5 for that one. All right. Then let's combine like terms. 2x plus x is 3x. 7 plus 13 is 20. And then 4x minus 1. Subtract 3x from both sides, so 20 is greater than x minus 1. You know what? I'd rather move all the x's to the left. Negative x plus 20 is greater than negative 1. Subtract 20 from both sides, so negative x is greater than negative 21. Then I need to divide everything by negative 1, and anytime that you divide by a negative, this sign flips. So x has to be less than 21. All right, last one. 4x plus x is 5x. 13 minus 1 is 12. Subtract 2x from both sides. Subtract 12 on both sides. And then divide by 3, and x has to be bigger than negative 5/3. Okay, the best way to explain the way that you come up with what your answer is by looking at this all on a number line. So negative 5/3 comes first, and then 7/5 would come next, and then 21. So this is my number line. Oh, I didn't mean to make 21 vertical. 21. There we go. Okay, so x has to be bigger than 7/5. So from here, it's got to go this way. You know what? I'm going to do this with highlighter. It has to go this way. Okay. And then x has to be less than 21. So this one has to go this way. And the last one, x has to be greater than negative 5/3. So that would be this way. So the only one where all three of them overlap is right here. So that's our answer. 7/5, and it's always going to be less than x's, and then 21. So this kind of just gets the boundaries because this middle portion is always going to be the same. That's not going to be any different. All right, very last thing, possible side lengths. All right, So anytime that you have possible side lengths, you add them together and subtract them from each other, and it's between those two numbers. So if you're given a triangle with sides 3 and 5, if you were to add those together, this side would have to be less than 8, so it could be 7 or less. If you were to have 3 or 5 and you subtract those from each other, that would give you 2, and it has to be bigger than that, so it would have to be 3. So in other words, you add them, then you subtract them, and then your answer is between those two numbers. Oops, this is 3 and 5. So whenever I add 3 and 5 together, that gives me 8. When I subtract them, that gives me 2. So my answer has to be 2 is less than x is x. I don't know where that came from. Is less than 8. So you're going to add them and subtract them. That's all that is. So an example, another example, is if you have 5 and 9, what are my possible third sides? 9 minus 5 is 4. 9 plus 5 is 14. So you do less thans with an x. My next example is 3.8 and 9.2. Let's subtract them. 9.2 minus 3.8. That would give you 5.4. And then 9.2 plus 3.8 would give you 13. So less than and less than. And those are your answers for those types of problems. And we are done with notes.